Okay, greetings, Integration Nation. Welcome to another MIT Integration Bee problem. This problem is from the 2006 Integration Bee number 2. So let's go ahead and get into it.
Specialize in science and mathing, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe-to-toe, impeccable, splitting your back, son, simple as addition and subtraction, black thought, the infinite relax one.
All right, so before I get started on this problem, just a few comments. I do want to say I already solved the problem off camera, so I'm not doing this live. And I need to fully admit I had some difficulty solving this problem. And so when I do the problem, I'm not going to just solve it straight. I'm going to go through what I did off camera. And so it'll be sort of like I'm doing it live, and I'm going to point out the problems that I encountered and kind of show you the thinking that I utilized to overcome those problems. So I think it's more beneficial than just watching me solve the problem proper and go through straight to the answer versus me showing you perhaps when I do a strategy that doesn't work or a technique that doesn't work, and what do I do from there? How do I recover and overcome that particular obstacle? So that's pretty important as well. So I don't want to fabricate as though I never have issues. So even me, when doing unconventional problems, since I've done a lot of problems, obviously, I tend to know how to the right strategy to use on most problems because I've done so many problems. The more problems you've done, the more likely you are to utilize a correct technique. But however, when a problem is somewhat novel and unconventional, sometimes what you think is the right technique doesn't always work. And there's a bit of luck of whether you get it right the first method or technique you use or not. But of course, that luck increases based on your experience of doing problems. So I kind of want to show you the process I went through to solve the problem. Again, there was a point of difficulty. We did overcome it, but it's good to point out what that point of difficulty was. So let's go ahead and dig into the problem. So initially, I looked at the problem as u sub, and down here, I wanted to make this 1 plus u squared and kind of set it up for completing the square problem of the arctangent structure. So I said, let u equal x to the power of 1 over 6. And why x to the power of 1 over 6? Because x to the power of 1/3 is x to the power of 1 over 6 squared. And then I said, so let du equal 1 over 6, x to the power of negative 5 over 6 dx. And then let 6 du equal x to the power of negative 5 over 6 dx. And this is where the problem lies. Let me try to make that somewhat straight. If you know me, you know my writing tends to lean. This is where the problem really started. So here's where things didn't look right, but I still felt pretty good. And the reason I felt pretty good is because, this doesn't match this. What I would like to have is x to the negative 1/2 dx. But the fact that this guy is, u to the power of negative 5, the fact that it's a multiple of u gave me some promise. I felt a little optimistic. That was false optimism, but I felt it nonetheless. So, I thought about this in a form of being u to the power of negative 5. But, that thinking was flawed, and it's really not gonna allow us to match it with this. So, and I thought for a while about that. And then I thought about abandoning this whole strategy of making u x to the power of 1 over 6 and briefly thought about other things. I moved the x to the 1/2 down and distributed that, and that didn't seem very promising. So there's a few things that I kind of tried that weren't really going anywhere. And an issue I have, and a lot of times it's an issue. In this case, it ended up being a benefit. Is when I have a technique that maybe it didn't work, but it's so close. It's very difficult for me to abandon that technique. I'm very reluctant to do so. So even though I was thinking about these other different strategies, I kept going back to this, and I didn't want to abandon letting u equal x to the power of 1 over 6. And then I finally thought about how to make it work. I mean, it's like normal u substitution. It doesn't always match when you find du and you figure out something to multiply by. to make it match. So that's common for U substitution. And so I thought about that, and I thought, normally it's just some number we multiply by, but we can multiply by some variable as well. And so I thought about, what can I multiply by this to make this match x to the power of -1/2? And, if you just think of it, x to the power of -1/2 is x to the power of -3/6. And so in order to get that, I should multiply this by x to the power of 2/6. So again, if I multiply x to the power of -5/6 by x to the power of 2/6, I get x to the power of -1/2 dx, match. Now I have to do it to both sides, of course. So this is 6x to the power of 2/6 du. And now you may say, well, you got an x with a du. What's that all about? Well, x, and is that hard? My writing might be my handwriting might not be the best here, but this is saying x to the power of 2/6. X to the power of 2/6 is u squared. So this is 6u squared du, and that equals, again, if I multiply this out, x to the power of -1/2 dx. So now we have a very beautiful match. So x to the -1/2 dx is 6u squared du, and on the bottom you'll have 1 plus u squared. So what it will look like with the substitution is 6u squared over 1 plus u squared du. Now we're looking good. Now it happens not to be, not to be of the strict arctan format, because there's not a constant up here. There's some variable. But the fact that these powers are equal, the degree of the top and the bottom are equal, allows us to simplify, using basic algebra. So I can just, do simple division to get this in a format better to be integrated. So if I do my division, and so I'll just write this as u squared plus 1. So u squared plus 1 divided by u squared, and u squared plus 1 will go into u squared one time, and that'll be u squared plus 1. And then when I subtract, I'll get a remainder of -1. So that'll be -1 over u squared plus 1. Now, this is in a form which is very easy to integrate. And so now we can integrate this quite easily and solve the problem. So the integral of 6, and when I did this off camera, I forgot about the 6. I do that a lot when there's a number in front. I'm not going to now. So when we rewrite this, this is going to be 6 times the integral of 1 minus 1 over u squared plus 1 du. All right, and this, of course, is very easy stuff to integrate. And so the integral of 1 would be u, and the integral of 1 over u squared plus 1 would be the arctan of u plus some constant. And so the last thing we need to do is simply write u in terms of x, and u was x to the power of 1/6. So this is 6 times x to the power of 1/6 minus the arctan of x to the power of 1/6 plus c. So there you have it. So I hope I did a good job of highlighting the difficulties this problem caused with me, and the way I found a way to get out of those difficulties. Hope you enjoyed this video, and we will see you next time.
Specialized in science and mathing, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe-to-toe, impeccable, splitting your back, son, simple as addition and subtraction, black thought, the infinite relax one.